Hey guys, I'm bad with math and today I'm going to be showing you how to use the unit circle. When you get to classes like trigonometry or pre-calculus or anything higher, you'll be forced to use the unit circle really. And in geometry, you may have already experimented with trigonometric ratios like sine, cosine, and tangent. But in today's lesson, we'll be covering how to use this unit circle that I have here in order to find specific trigonometric values that are commonly used in math. So the first thing that we have to go over is the conversion from degrees to radians. The unit circle uses radians more than degrees, and the reason for it is because radians give a more accurate measure as to what angle we have. So radians is just another form of an angle measure. So let's say we have an angle of 30 degrees, and I'll be using the Greek symbol of theta to determine what angle we're using. I can tell you that this is the same as pi over 6. And that's because there's a conversion factor between radians and degrees. If you have something in degrees, like 30 degrees, and you wanted to convert it to radians, you would write 30 degrees times the conversion factor. So the conversion factor comes from the formula for the circumference of a circle. And that would be that the circumference of a circle is equal to 2 pi r. Now, on the unit circle, it's called the unit circle because the radius is 1. Unit meaning 1. So, in the unit circle, the circumference of the unit circle is 2 pi because radius is 1. So, the circumference is 2 pi. And we know that we're going to be working with degrees. So, if one revolution, meaning one like loop around the graph, is 2 pi, and we also know that one loop, one circle, is 360 degrees, we can say that 360 degrees is equal to 2 pi, and then we can divide by 2 to say that 180 degrees is equal to pi. So that is how we get our conversion factor for degrees and radians, which means that when we're converting 30 degrees to radians, we'll multiply 30 degrees times, and then we'll put on the bottom 180 degrees. And what we saw from our calculation right now was that 180 degrees is equal to pi radians. So we're going to write pi, and then we're going to put rad, as in radians. So this means we're just going to simplify here. The degrees cancel out, and then these simplify to 1 and over here 6. So we're going to end up with pi over 6 radians. However, in math, as you notice, I didn't write the radians here, and that's because we don't tend to write the radians unit when it's assumed that we're using radians. So there's no need to write radians. So that's how you would convert between degrees and radians. And now we're going to take a look at our actual unit circle. So we know that a right angle is 90 degrees, which means that this section right here, if we're starting here at 0 degrees or 0 radians, we can say that here is 90 degrees. And if we quickly find how much 90 degrees is in radians, well, we're going to get 90 degrees times pi radians over 180. So that would just be pi over 2 radians, which is what I write up there. So from here to here on the unit circle, the circle is moving pi over 2 radians. The angle here is pi over 2 radians. So I'm going to put pi over 2 here on the tops of each one, or not pi over 2, but the angle measure, and that'll be in radians. Now you can do on the unit circle, this bottom one here is 30. This is 45 and this is 60 degrees. So in radians, the easier way to remember it is pi over 6 on the bottom, pi over 4, and pi over 3. On the unit circle, you're going to end up using, for angle measures, 1, 2, 3, 4, and 6. And of course 0, but for instance, you see the 2, 3, 4, and 6 on the unit circle here. And then we know that 180 degrees is pi radians, so this would be like pi over 1. So that's where the 1 is as well. So this is 2, 3, 4, and 6. That's how we remember the angle measures. Now, we need to remember the coordinates of the unit circle. So we know the radius is always 1 on the unit circle. But there are specific points where the circle lies right here. Specific x and y coordinates. So a simple trick to do this, and I'll amplify it here. Let's say we have our first quadrant right here. This is pi over 2, pi over 3, pi over 4, pi over 6, and 0. If we wanted to find the coordinates, we would set up these 3 right here. We're going to go down the line. So we're going to do 2 lines, 2 lines, and 2 lines going downward, right? Then we're going to put a 2 under all of them. And then we're going to put a comma in the middle of them. These are our points, our coordinate points. So now what I'm going to do is I'm going to write 1, 2, 3 going down on the x side, and then 1, 2, 3 going up on the y side. So 1, 2, 3, 1, 2, 3. And then you square root the numerator of each one. So if you square root 1, we'll just get 1. So I won't write it for the 1. But we square root 2, square root 3. Same here for the 1. It'll stay as 1. Square root 2, square root 3. And now here we have the coordinate points for pi over 3, pi over 4, and pi over 6 radians. Now you're wondering, for 0 and pi over 2, what would be the coordinate points? Well, that's really simple. 0 is a straight line. It makes not a straight angle, but there's no like acute or obtuse angle for 0 radians. So realistically, our points here would just be, because it doesn't go up at all in the y values, it's just 1, 0. And conversely, for pi over 2 radians, it doesn't go horizontal in any way. So it's just 0, 1 for pi over 2 radians. So these are very simple to follow. This is the way to memorize the first quadrant. And I know the unit circle has a lot of other points, but this is the important point to remember. Now on the unit circle, you'll learn that cosine of your angle is just equal to your x coordinate, and sine of your angle is equal to your y coordinate, which means that the tangent of your angle, which is the sine over the cosine, is going to be your y over x. So if you were asked, find the cosine of pi over 6, well, we think our unit circle, we can draw it out if we want, the first quadrant. And then our x value is just the root of 3 over 2. And then that's our answer. Now, how would you remember the rest of the quadrants? Well, this is really simple. What we're going to do for the rest of the quadrants is have a mnemonic. Let's split the quadrant into 4, and then I'm going to write A, S, T, C. Now this is a trick my calculus teacher taught me. All students take calculus. Quadrant 1, 2, 3, and 4. all students take calculus. Now, we take the first letter of all students take calculus, all students take calculus, and then those decide what trigonometric functions are positive. So the A stands for all of them. Sine, cosine, and tangent are all positive. The S stands for sine, the T for tangent, and the C for cosine. Meaning that if I were tasked to find tangent of some angle where the angle is in quadrant 2, well, it's tangent and only sine is positive in quadrant 2. So this answer must be negative, 100%. Now, this doesn't only apply for sine, cosine, and tangent, but also the reciprocal. So if sine is positive in quadrant 2, that means cosecant is also positive in quadrant 2. Cotangent is also positive in quadrant 3. And secant is also positive in quadrant 4. So that's how you know if it's positive or negative. Additionally, I spoke about how 1 revolution is 360 degrees or 2 pi radians. And what that means is that if we wanted to get, let's say we had to find the tangent of 13 pi over 6. Now, I know that 2 pi is the same as 12 pi over 6. 12 pi over 6 is less than 13 pi over 6. So this means this is tangent of 1 revolution plus a bit of the second revolution. So as you notice, as you revolve around the circle, you get to the same point eventually. So here, the angle is 0, but it's also 2 pi. And we can also have a negative angle, which is where you revolve backwards. It's supposed to symbolize direction. So we can also have an angle here of negative 2 pi. So if I were to task to find the tangent of 13 pi over 6, what I would do is I would take this angle and I would minus it by 2 pi, which I know is 12 pi over 6, which means that I'd have pi over 6. So I'm really finding the tangent of pi over 6. And when I do that, I'm going to think of the unit circle. I know that at pi over 6, my coordinate points are the root of 3 over 2 and 1 over 2, based on the trick that I showed you earlier. And since I have pi over 6 here, and tangent is my y over x, my y is 1/2, and my x is the root of 3 over 2. The 2's can cancel out from fraction division, and we'll end up with 1 over the root of 3. And if you want to simplify that, that's the root of 3 over 3. And that is tangent of 13 pi over 6. So now you're probably wondering, what about the other quadrants? We spoke about how if they're negative or positive, but how do I know which angle is which? So if I just told you that this angle right here was 7 pi over 6, you would wonder how I got to that result. Obviously, you could do the radian to degree conversion or degree to radian conversion, because you know this goes from 0, 30, 45, 60. So you would have 90 here. You add 30, then add 15, and then add 30 again for the degrees. Or what you could do is you could memorize how the quadrants work. So in the first quadrant, the angle measures, for the angle measures, we have pi over 3, pi over 4, pi over 6. What do you notice about the numerator? The numerator is just pi. 1 pi, I'll specifically write 1 pi. So that's really easy. The numerator is just 1 pi. These are the numerator patterns. For quadrant 2, the angle measures on the unit circle are 2 pi over 3, 3 pi over 4, and 5 pi over 6. Now if you notice a trend, you take the denominator, which I'll represent as d, and then minus 1 from the denominator, so 6 minus 1 is 5, minus 1, and then multiply it by pi. And that's how you get your numerator for any angle in quadrant 2. So if I were given cosine of 2 pi over 3, I know that that means the cosine is in quadrant 2. Now if we have quadrant 3, I told you 7 pi over 6, this is going to be, here this is over 4, so it's going to be 5 pi over 4, and this is going to be 4 pi over 3. Instead of subtracting 1 for quadrant 3, you're going to add 1. And then that's the numerator pattern, right? 4 plus 1 is 5, 3 plus 1 is 4, and then multiply by pi. And then for the last quadrant is the most complex, I guess. And we can fill in here. This would be 3 pi over 2. For the last quadrant, the angle measures are 5 pi over 3, 7 pi over 4, and 11 pi over 6. These are some pretty big numbers. Basically, what I did was I multiplied the denominator by 2. So 6 times 2 is 12, and then subtracted 1, 11. So 2d minus 1, and multiply by pi. Well, that's just for the numerator. And now if you notice, each denominator is 3, 4, or 6, right? So it's kind of like reflected almost. If there's a 3 here, there's going to be a 3 here, 4 here, 4 here, 5, 6 here, 6 here. So it's reflected over here across the y-axis, and it's also reflected across the x-axis. So 6 here, 4 here, and 3 here, making a nice even pattern to envision on the board. And then that's how you'll be able to figure out which quadrants they're in just based off the given expression. So if I'm given to solve cotangent of 7 pi over 4, well, the first thing I do, and what's really important is when you get one of these, you have to think, don't think of it like this angle. You're going to have to think of a reference angle. And how to find the reference angle? Well, if it's over 4, my reference angle is over 4. So I'm first going to look for cotangent of pi over 4. And the same thing happens if it's over 6 or over 3. Just think of it without the extra numerator. Just pi. Like imagine it with a coefficient of 1 instead of 7. And then we're going to use the coordinates at pi over 4, which is root of 2 over 2 and root of 2 over 2. And cotangent is the reciprocal of tangent, so 1 over tangent of pi over 4. And then tangent is y over x, so tangent of pi over 4 would be y over x, so root of 2 over 2 over root of 2 over 2, which is just 1. So this is really 1 over 1, aka 1. So cotangent of pi over 4 is 1. And then if we wanted to find the cotangent of 7 pi over 4, we think back to our all students take calculus. This we know is in quadrant 4 because 4 times 2 is 8 minus 1 is 7. So it's in quadrant 4. And then if I wanted to know what the value was for 7 pi over 4, if it was positive or negative, because we know it's going to be 1, I would think all students take calculus. And then in the fourth quadrant, we have C, which means cosine and secant are positive, not tangent or cotangent. Therefore, our answer has to be -1. And that is how you use the unit circle.